Then in that case, I can move right along and introduce our next speaker. He was also with us last year for the first BIM Symposium. Monte Hindbo is founder of Spearhead Design Incorporated. Now that's a company that merges the experience of the tradesman with the virtual design of the draftsman. Envisioning BIM's potential, Spearhead prides itself with keeping up with the latest in software and hardware, developing new and innovative construction processes, and I'm going to let him tell you all about it. Welcome, please, Monte Hindbo. Here he is. Just going to refresh that for you, Monte.
Thank you. This is great. Hello, I'm not sure who wrote that introduction, but my name is Monte Hindbo, and I'm actually a plumber. What I've done over the years is just noticed a real inefficiency in construction, and it's one thing that drove me to using BIM. I had a couple comments. I guess we're way ahead of schedule, so I can rattle on for a while maybe.
Don't think that.
A couple quick comments. A good BIM implementation plan is thinking about starting with the end product. I listened into the other speakers. I was thinking that I'm just wondering how many manufacturers do we have in the audience today? Is there one? Yeah, that's a group I think that maybe we're all overlooking is the manufacturers. They're a group that could be sharing their models, whether it's a sink or an air handling unit or whatever that we moving forward in BIM that we could all use. Anyway, that's not part of my speech here, but I'll get started here. Maybe before I get started, I'd just like to say one thing. Is this going to go up? Maybe a little bit about myself. I've been doing 3D modeling since '97 and is just more for fabrication and construction. But I'd also like to say happy Movember to everybody. I wouldn't wear this thing if it wasn't for Movember, and I'll be glad when Movember's over. So for the rest of you guys out there that are putting up with humiliation with me, hats off. I don't think we'll ever beat that guy. He's got us beat. So Spearhead Design is, I guess, more of a design assist business. We also have a manufacturing business where we do process piping and mechanical stuff. But we have a large toolbox of what I call BIM tools. A little bit of everything. I'm really impressed that I haven't heard the word Revit over and over and over today. I'm really happy about that. I really like a open platform that we can use a little bit of everything. Some of the tools we use, or some of the software is AutoCAD, of course, CADWorks, Navisworks, QuickPen, Pipe Designer, Duct Designer, Revit MEP, Point Cloud. We have a whole bunch of programs that I call our soft BIM tools. Some of the other hard BIM tools that we use are laser scanner. We have Total Station for doing layouts, CNC plasma machines in the shop and stuff, much like Reza and his manufacturing of houses. We use tools for manufacturing metal. But today what I wanted to talk about was laser scanning. So I'm going to try to not rattle on about everything else and maybe just focus on how we use laser scanning as one of our BIM tools. So what is laser scanning? I guess in a nutshell, it's a fancy machine that twirls around and measures millions of measurements. It just takes measurements and puts a point on the end of every one of those measurements, and that's what you call point cloud. So how do we use our scanner for different things? I have a picture here of, I guess it's a gas plant that we've scanned. We've used that to model in new piping, new structural, and for fabrication. So we'll go in and scan something, model it, and we do that for fabrication. We also use our scanner for reverse engineering small pieces. It could be a base plate for something that we know we need to copy. We'll scan it, and then we can put that back into our CNC plasma machine and cut it out type thing. So the first step to scanning is basically doing the site scans. How the scanner works is it's a line of sight. So we take the scans. A typical scan takes, it's not very long, takes maybe 6 to 10 minutes long. Then once the scan is complete, we move it to a different location to do another scan. And once you have multiple scans, you can put them together and it creates the 3D image, which we use for our modeling and stuff. Our scanner also takes a 3D photo, 360-degree photo, of everything that while it's scanning. It takes that color and puts the color onto the point cloud. So you end up with a full color point cloud, which is really invaluable. I don't know if anybody's worked with point clouds, but the black and white ones are really, really difficult to work with. What else can I say? These things are quite precise. They'll do about 2 millimeters and 120 meters. So when you do multiple scans and put them together, you end up with a really accurate capture of exactly what was there at that time. They'll even do up to HD scans. They take hours, but they do work. One of the benefits to scanning compared to conventional data capture is that it's very quick, efficient. Normally you have a couple guys out on site, maybe ladders, zoom booms, what have you, taking measurements. And in a good day, they might take a few hundred measurements, whether it's with tape measure or with a total station or something. Then they go back and try to put that into usable data, so you'll end up plotting it in AutoCAD or some type of thing like that. With laser scanning, you have one guy, you can go out, capture millions of measurements in the same time period without the use of ladders or without the use of zoom booms or whatever you need to access those points. It's also a great place for in the oil and gas where we have H2S and other environmentally dangerous parts or places. The scanner is a great tool. You can go in and capture all the data that you need in a very short period of time and get out. So it really lessens the exposure to, I guess, the elements. Confined space is a good example of that. So I'm going to jump ahead a little bit of my presentation here and give you one of the other tools that our scanner does. It has, as before I said, it takes 360-degree photos of each scan and then stitches them all together. So what we have is a web share tool which takes each one of these scans and puts it onto the internet. Then we give our clients or customers access to those scans. So, with simply all they need is a web browser, they can go on and look at their scans and walk through their complete, building or whatever it was that we scanned. So once you're into this is a a snapshot of the web browser. So it's made very, very simple so that anybody can use it. This is a gas plant. Up on the top left, you see there's icons. You can pick the individual scans that way. On the right side, there's a plan view where all the scans were taken of the area. I should note that's all dimensional as well, so you can zoom in and out of that and get fairly accurate measurements to in areas of the scans. And then the third one was the photo bubble. So what you can't see in this one is you can pan around, zoom in to, read valves, read data. A lot like kind of the Google Maps when you're the street maps where you can go in and look around. So what advantage this has is that designers, engineers, construction, everybody can use this tool for collaboration. They don't need to leave their office and drive 3 hours to the construction site to talk about something. They can all go online, have a look at the scans, see exactly what they have out on site. It's exactly what they want to do about it. And then the other thing we do is we host, we have a smart board, so we will host WebEx meetings or smart board meetings with our customers so that they can go on and actually make design decisions. Here you see, I don't know, they must have been adding some piping or something into that spot. We have a few clients that, Suncor is one of them, that there's a group of engineers, they don't even go out to site and look anymore. They just phone us up and send us out to go scan it and then post it onto the internet so that they can do their designs and hash through issues without driving. We also, as I said before, we have a manufacturing business where we do lots of process piping and stuff, but we also have a little wrought iron business that was kind of a hobby that got away on one of my guys. And he actually uses the scanners now for almost all of his stuff. So if he's doing spiral staircase, or in this case, like a little gate, he'll actually go scan it and bring it back to our design team to get all the measurements. Because every time he goes out there, he doesn't ever get them all. He's always missing one. And then this way he can, create a rough design really quick within minutes and show, his customer or whatever what they're going to get. So this is just a little quick step through of the process. Once we've gone out and scanned an area, this one here is the Calgary Airport, so that's a face of the WestJet building. And what we're working on now is they're adding a new terminal to the edge, so they have to tie on to that existing WestJet building there. So we've created a point cloud and have placed that point cloud with the survey data and giving that back to the design team so that they have every measurement or dimension that they need to do their design. So there's just a photo of the same thing. So once all our scans, you can see on the left, it has the multiple scans. They're all processed with and stitched together, so it creates the 3D model, and then it creates basically a black and white point cloud. And that's something that's very hard to work with, so we go back and reprocess it and add the color to it, which is really just a click of the button, but it sure makes a difference for when you're working with them. So from that point cloud, a lot of times it's quite heavy. You've heard all the massive data. Point clouds aren't something you just email. So a lot of times what we'll do is we'll take that point cloud and we'll model it. And this can be modeled in anything, Revit, AutoCAD, whatever tool you like to use. Point clouds can be brought into pretty much any software these days. So once you're done with point cloud, you end up with just a 3D model that's really easy to use for the design team. So I said before, I'm a plumber. I'm not really a public speaker, so I got a lot of pictures here to go through and just show you the other ways that we use our scanner. That's just a picture of the overall scan. So what we do is we do a lot of modeling of process piping systems and equipment. So we actually model in the scans. For the most part, they're fairly easy to work with. You don't need supercomputers by any means to use them once they're processed right. They're also almost like a reference, so you can turn them on and off while you're doing your work. So again, these are just a series of images of some of the process piping that we've done. The scans are incredibly accurate. When you're modeling in a scan, you know right away what the issues are and what the problems are going to be. One of the advantages of doing this in the oil and gas industry anyway, they don't like to shut the plants down too often. It just costs them money every day they're down. So we can go in and scan and do a design and fabricate the bulk of that job before they need to shut it down, and it saves tons of time on schedule. This one here is I put this one in here. This slide is it's just a vessel that was added into an existing building. So we went and scanned the vessel and then created a model of it and put it into our design. Again, point clouds are fairly easy to use. It's not anything to be scared of. It's they're quite easy. Here's just a slice of the scan when we're working in it. We also work quite closely with the construction team for installation as well. We'll make sure that they have all the necessary tools and programs and stuff so that they can actually utilize what we've done. So we do a lot of kind of hands-on training with them as well. So one of our other projects that we've done was a Nestle plant. This Nestle plant had a team of engineers that was in Florida, and the plant here is in Alberta. They would fly into Alberta once a month for a week and go through, take pictures, and try to come up with a way to revamp their plant. They wanted to do kind of a whole changeover in all kinds of different equipment and places. So after about 3 or 4 of these trips, they decided that maybe it wasn't going to work, and they'd end up having to fly or move a few of their guys down for the next 6 months to go through the design. So we proposed that we'd go and do a complete scan of their facility. So that's what we did. Went through and scanned their entire facility, put it onto the web share so they could all use it. Created an online project for them. I think it was a base camp project so that they can work with their maintenance guys, etc. And a come up with a plan on how to deal with this massive change they wanted to make to their plant. So after they went through and did a bunch of sketching online, they're pretty impressed that they didn't need to fly down and take pictures anymore. So we went to the next step and started modeling their equipment for them. And what we did was we modeled existing equipment that they had in other plants, created a 3D model for it, and then just give them the models. Some cases we placed them where they wanted them so they can see the impacts. Other times they just use those models themselves in AutoCAD or Navisworks to make their decisions. So these are some of the snapshots, if you will, of that. Again, the laser scan just is a great tool for giving you confidence in manufacturing. I don't know if you can see there, but it's so accurate that the flange bolts line up. You can tell if their flanges are out 1 or 2 degrees. So it allows us to fabricate all that stuff off-site and then just show up and put it in. One of the other things that we do is construction monitoring. We'll do places when they have underground, we'll come in and do a scan before they bury it. This one here shows the model, which was the intent of the, I guess this would be a tank farm. So once they put it in, we went and scanned it and then overlaid it with the model to see, what the differences were. So you can tell if it was built to design. That's just some underground pictures. So what you're looking at there is an actual scan. It's not the photo. Even back to the little wrought iron railing again. So again, this is back to our construction monitoring. This was plumbing wall. It was a pod that they put into the Gana building. So the whole plumbing came in one big module and they plunked it in. So what we wanted to do was find out what everything was in the walls before they closed the walls up. So we did a few quick scans of the mods as they put them in, and then once they close the walls and they have a record of exactly what's in that wall and where it is. The scanning technology is actually, it's fairly inexpensive. It's a great tool. Lots of the construction are purchasing them and getting into this one. This is a photo that I got from my friends at Ellis Dawn at the Calgary airport. So they're doing all this heating piping in the slab, but because of the job schedule, they have to go back and do a bunch of coring afterwards. So they purchased the scanner and are doing scans of all the in-floor heating before they pour the concrete. So when they go back, they'll have exact record of where that is. It doesn't look like they have much room left to put anything through there, but that's just another use that you can use that for. I guess as built conditions is a great use for a laser scanner. You have a record of what was there at that time, so we do a fair bit of as-builting with our scanner. One of the other things we do is map out critical systems for NDE testing, things like that. In this case, they have to take and test that piping at certain points over and over again every year. So instead of trying to go back and figure out where it is or draw all that isometrics of every piece of pipe with all the test locations on it. We would go through, scan it, quickly overlay the model in CADWorks software and spit them out a spool drawing of it. And that's about it for my laser scanning presentation. It's just one of the tools in our toolbox that we use every day, and I think it's something that people shouldn't be scared of. It's not all that complicated, and it's a great tool for construction. And that's the end of my presentation. Thank you.